Understanding VM resources, CPU, RAM, disk, and network. Virtual machines, VMs, are a powerful tool for running multiple operating systems on a single physical machine. But to get the best performance, you need to understand how to allocate and manage key resources: CPU, RAM, disk storage, and network configurations. Each of these plays a crucial role in determining the efficiency, speed, and stability of a virtual environment. In this lesson, we will break down each of these components in detail and explain how to optimize them for different use cases. Understanding CPU allocation in VMs. The CPU, Central Processing Unit, is the heart of any virtual machine, determining how fast it can execute tasks. In a virtualized environment, a hypervisor manages CPU resources by allocating virtual processors, vCPUs, to different VMs. The key thing to understand is that vCPUs are not physical cores. They are virtual representations that share the available physical CPU cores of the host machine. How many vCPUs should you assign? When creating a VM, you must decide how many vCPUs to assign. The ideal allocation depends on the host's hardware and the intended workload of the VM. A few general guidelines include: basic tasks, 1 to 2 vCPUs. If the VM is running a lightweight OS for simple tasks like browsing or documentation, 1 or 2 vCPUs should be enough. Software development and testing, 2 to 4 vCPUs. If you are running development environments, virtualized IDEs, or basic application testing, 2 to 4 vCPUs provide a good balance between performance and efficiency. Heavy workloads, 4+ vCPUs. Running high-performance applications such as databases, video editing software, or gaming requires 4 or more vCPUs. However, be mindful of CPU overcommitment, where too many vCPUs are allocated across multiple VMs, potentially leading to performance issues. Managing RAM allocation in virtual machines. RAM, random access memory, directly affects a VM's ability to run smoothly. Unlike CPU, which can be shared more dynamically, RAM allocation must be planned carefully because memory assigned to a VM is reserved exclusively for that VM while it is running. Understanding virtual disk storage. Storage is one of the most critical components of a virtual machine because it determines how much space the VM has for its operating system, applications, and files. When creating a virtual machine, you must choose the type of disk storage and how it should be allocated. Understanding virtual network configurations. Networking in a virtualized environment determines how VMs communicate with each other, the host system, and external networks. Hypervisors provide multiple networking modes, each suited for different use cases. Final thoughts: optimizing VM resources for best performance. Configuring CPU, RAM, disk, and network settings correctly is crucial for ensuring a VM runs efficiently. Here are a few general best practices. Monitor performance regularly. Use built-in hypervisor tools to track CPU, memory, and disk usage. Balance resource allocation. Avoid overcommitting CPU and RAM, as it can degrade performance. Use SSD storage whenever possible. This can significantly improve VM responsiveness. Choose the right network mode. Pick a networking setup that matches your VM's needs.